For the problem 2, part A, we need to find the probability that x2 equals to 1, and we can rewrite the probability of x2 equals to 1 as the probability that x2 equals to 1 under the condition that x1 equals to 0 times the probability that x1 equals to 0 plus the probability that x2 equals to 1 under the condition that x1 equals to 1 times the probability that x1 equals to 1. And plug in the value we have known from the problem, which is 0.4 times 0.2 plus 0.7 times 0.8 and equals to 0.64. And for the problem B, we need to find the probability that x3 equals to 1. Similar to part A, the probability that x3 equals to 1 equals to the probability that x3 equals to 1 under the condition that x2 equals to 1 times the probability that x2 equals to 1 times the probability of x2 equals to 1 plus the probability that x3 equals to 1 under the condition that x2 equals to 0 times the probability of x2 equals to 0. Because from part A, we know that the probability that x2 equals to 1 is 0.64. So its counterpart, x2 equals to 0, is 1 minus 0.64. So based on this, we have 0.7 times 0.64 plus 0.4 times 1 minus 0.64, which is equals to 0.592. And this is for the problem A and problem B. And for the problem C, we need to find the probability that x1 equals to 0 under the condition of x3 equals to 1. And actually, we can rewrite this probability by applying the Bayesian formula. So this probability can be rewritten as the probability of x1 equals to 0 at the meantime x3 equals to 1 divide the probability that x3 equals to 1. And we have already got the probability of x3 equals to 1 is 0.592 in problem B. So we just need to calculate the probability of x1 equals to 0 at the meantime x3 equals to 1. And we can rewrite this probability by applying the Bayesian formula again. This can be rewritten as the probability of x3 equals to 1 under the condition that x1 equals to 0 times the probability of x1 equals to 0. And we know that the probability, we have already calculated the probability of x1 equals to 0 in the part A. So we just need to calculate the probability of x3 equals to 1 under the condition that x1 equals to 0. We only need to calculate this part. And this part can be expanded the probability of x3 equals to 1 under the condition that x2 equals to 1 times the probability that x2 equals to 1 under the condition that x1 equals to 0. We have the limit constraint that x1 must equals to 0. Plus the probability that x3 equals to 1 under the condition that x2 equals to 0. We have no constraint about the value of x2 times the probability that x2 equals to 0 under the condition that x1 equals to 0. And then we just need to plug in the value, which is 0.7 times 0.4 plus 0.4 times 0.6, which is 0.52. So here we have already calculate, and so the value of the probability of x equals to 0 at the meantime x3 equals to 1 is 0.52 times the probability of x1 equals to 0, which we have from the problem, is 0.2. And let me get this part smaller. So we have already known this value. So we know that the probability that x1 equals to 0 under the condition of x3 equals to 1 equals to divide the probability of x3 equals to 0 is 0.592, and we get our final answer is 0.1757. Based on the problem 1, 2, 3, actually we can rewrite this formula by matrix format. So for the problem D, we know that the probability of xn equals to 0 and xn equals to 1 can be rewrite as the matrix format, which is the multiplication of, this is the condition of n equals to 1, times the chain that we got from the problem description here, and times the power of n minus 1, as we can verify that n equals to 1, this is for 1 in this matrix. So the probability of x1 equals to 0 is 0.2 as denoted in the problem. So when we need to find the probability of xn equals to 0 when n approach to infinity, which is to find the matrix multiplication value when n equals to infinity. Let me again smaller this part. So to calculate this limit, we just need to know that we have to apply the formula of a1 minus a as they are counterpart of each other times the chain matrix is equals to a1 minus a, and we solve this equation, we got that a equals to 3 divided 7. So the probability of xn equals to 0 when n approach infinity is 3 divided by 7. And this is for the problem 2. I think for the problem 2, we need to have the ability to derive formula from n to n from derive formula based on n equals to 2, 3, 4, 5. And we also need to know how to calculate the matrix limit.